Hello and welcome. Before watching this video, you would have learned about double integrals and how to evaluate them. By watching this video, you will learn some properties of double integrals. Firstly, recall that with single integrals, you are able to place the constant 3 that multiplies x squared outside of the integration symbol like this. Following which, you carry out the integration as usual. Now, with double integrals, you can do the same like this. Hence, the statement below expresses this rule in general, where if a function f of x and y is multiplied by a constant c, then you can place c outside of the double integration symbols and just integrate f of x and y as you would normally. Next, recall that with single integrals, if your integral is a sum of two different functions, you can perform the integration separately like this. The same can be done with double integrals of two different functions. You can write it as two separate double integrals, and evaluate them separately. Hence, this rule is expressed in general like this. A double integral of f plus g can be written as a double integral of f plus a double integral of g. Of course, notice that both double integrals are above the same region R. Similarly, if your integrand is a difference of two different functions, you can write them as a difference of two different integrals, like this. It is done this way for single integrals, and it is done in a similar way for double integrals. Again, we may express this rule in general like this. The integral of f minus g is the integral of f minus the integral of g over the same region R. With these rules, let us try an example. Given the double integral of f is 12 and the double integral of g is 7, both over the same region R, evaluate the following: the integration of 2 of f plus 3 of g and the integration of 3 of f minus 2 of g. Okay, let us explain. So, as you saw earlier, you may write the 2 outside the double integral, and you may write the 3 outside the double integral, and of course you may split them into two different double integrals. And now, using the values that you are given, make a substitution. And then finally evaluate to get the answer 45. Similarly, for the second one, you may take out the constant and take out the constant and express them as two separate double integrals. And now you are able to substitute the numbers in. And then that gives you the answer of 36 minus 14. That will be 22. And there you have it. That's the explanation for this example. So far, we know how to perform a double integral over a rectangular region. Now let's look at this example here. Here we have a double integral over region R. But look at the diagram of the region R here and notice that it is not rectangular. So how do we handle this situation? Well, the solution here is to divide R into two areas R1 and R2. Now we see that R1 is rectangular, and you certainly know how to integrate over a rectangular region. R2 here is triangular, and future lessons will show you how to integrate over a triangular region. Hence, this is the next property of a double integral. You are able to split the region R into R1 and R2, and you are then able to integrate over R1, followed by integrating over R2. In fact, given any general region R, you can split it in any way you wish. For example, you can split it into R1 like this, and R2 like this, and you can find the double integral over each split region, and adding them together to give you the answer for your original double integral. We have discussed quite a few properties of double integrals, so now we are ready to summarize. Firstly, a constant in the integrand may be placed outside the integration symbols. Like this, you can take the c here and place it outside the integration symbols. Next, if an integrand is a sum of difference of two functions, each of these functions may be integrated separately. So for example, if your integrand is f of x and y minus g of x and y, you may proceed to just integrate f separately and subtract the integration of g separately. Next, integrating a function f over a region R, the region R can be subdivided in any way you wish. And you can perform the integration separately over each subdivided area, like this over R1 and R2. Okay, so this ends our summary of the properties of double integrals. With this, we end this video. Thank you for watching.